Hey, what's up? We're gonna look at house robber 3 today. So let's read the problem. The thief has found himself a new place for his thievery again. There is only one entrance to this area, called the root. Besides the root, each house has one and only one parent house. After a tour, the smart thief realized that all houses in this place forms a binary tree. It will automatically contact the police if two directly linked houses were broken into on the same night. Determine the maximum amount of money the thief can rob tonight without alerting the police. So basically this problem is following the same logic as house robber 1, but instead of just using a list, it's using a tree. So let's take a look at an example. So we start at the root, and when we're at the root, we either have the choice to pick or not to pick. Not to pick. So what happens when we pick is that basically we eliminate the possibility of taking the children. So all this line will be eliminated and we have to go on to the next line. And one idea I initially had was like, why don't we just regroup each even level together and each odd level together? Like let's say we sum the values of this level and take this level and alternating between the odd and even levels. But the thing is, like you can see in this example, it doesn't quite work because in some branches it could be optimal to skip an extra node so you can be able to choose the next node. Like this one, the 5 is much greater than the 1, so we wouldn't want to be greedy with this and pick the 1 too early. So we really have to just apply the same principle as the first problem. We try picking the current node, setting a boolean saying that we picked the previous node and that we can't pick those ones, or leaving the boolean empty, not adding the value of the current node and just skipping to the next node. So I'm not gonna take the time to write the recurrence relation because we can see it clearly within the code. So we're just gonna look at that. So one good thing within Python is that each object inherits of the hash function. So you can use a LRU cache that will memorize your function automatically. And even if we have a node here, it's gonna hash it without any problem. So initially we can rob the root node, but if we decide to pick it like here, we set the can rob boolean to false. So when we arrive at the children, we can't actually pick them. And when we arrive at the children, we check if we can rob the current node, and well, then we check the possibility where we do. Otherwise, we just check here what happens if we skip. And the value of skipping a node is just the sum of the maximum values for each of their children. And if you decide to rob, well, you just add the value of the current node and do the same thing for the children without allowing to pick them. Then you check if it's higher than the answer you get by skipping the node. And if it is, you replace it and return the answer. And the base case is when you don't have a node anymore. So when you reach the null nodes, then you just have nothing to rob, so you return 0. And that's about it. Thank you for watching.